Hi, welcome back. In the last video, we went over laws of indices and how to use these in typical exam type questions. Today, we will be going over the next topic, surds, and how to rationalize the denominator. First, let's go over the two different types of real numbers. These are rational and irrational. Rational numbers are those that can be written as a whole number or a fraction, such as a third or 5/7. The other type is irrational, like pi and the square root of 2. These cannot be expressed as a fraction, as they have no pattern after the decimal point and continue forever. Any surd that cannot be simplified is an irrational number. Now that we know this, let's have a look at the rules when using surds. The first is that the products of two numbers in a root is equal to the product of the individual roots. The second is that the root of a fraction is equal to the root of the numerator over the root of the denominator. Finally, the third, any number is equal to the square of its roots, which is equal to the product of its roots. Let's have a look at some examples. First, root 48 can be split into root 16 times 3. The root of 16 is equal to 4, so the answer is 4 root 3. Next, root 9 over 4. First, split the root, so root 9 over root 4. Root 9 equals 3, and root 4 equals 2, so the answer is 3 over 2. Finally, the cube root of 17. First, rewrite it as root 17 squared times root 17. Then the product of the root squared is just the number in the root, so the final answer is 17 root 17. Here are some practice questions that get progressively more difficult. Pause the video and give them a try. Okay, let's go over the answers. First, root 4 equals 2, and root 6 cannot be simplified. Therefore, it's 2 root 6. Question 2. First split the root. Root 75 can be simplified to 25 times 3. The root of 25 equals 5, so the numerator is 5 root 3. The denominator can be simplified to root 36 times 2. The root of 36 is 6, so the denominator is 6 root 2. Therefore, the answer is 5 root 2 over 6 root 2. Question 3. Similar to the example, first split it into root 7 squared times root 7, which equals 7 root 7. And question 4. First simplify. Root of 25 equals 5 and root of 16 equals 4. Then multiply, and the answer is 20 over root 3. Now, let's have a look at a method you would be asked in an exam. Rationalizing the denominator. There are two ways to do this. The first is that if it is just the root in the denominator, then by multiplying both the top and bottom by the root, which is like multiplying by 1, so the value of the fraction is the same. The second method is if there is a value added or subtracted from the root, then you use the difference of squares, which is just flipping the sign of the second term and multiplying using FOIL. Again, here are a few practice questions to try this out. Pause the video and give them a go. Okay, let's go over these. For the first one, we multiply the top and bottom by root 7. So the answer is 21 root 7 over 7, which can be simplified to 3 root 7. Next, first multiply the fractions by cross multiplying and multiplying the denominators. Using our rules, we can multiply the roots. And now we simplify. Root 28 can be simplified to 2 root 7, and root of 196 can be simplified to 14. Now you can add 2 root 7 to root 7, and the answer is 3 root 7 over 14. For the last one, use the difference of two squares, so multiplying the top and bottom by 4 minus root 3. Now the top line is 12 minus 3 root 3 minus 4 root 3 plus 3, which can be simplified to 15 minus 7 root 3, and the bottom line equals 16 minus 3, which is 13. That brings us to the end of this topic on surds. But before you go, here are some challenge questions for you to try. For the first one, use the rules we went through. And for the second, rationalize the denominator using one of the methods from earlier. Thank you for watching, and if you found this video helpful, feel free to like the video. And if you want to stay up to date on new uploads, why not subscribe and turn on notifications? Thank you so much for watching, and see you in the next topic.